Why did a Boeing 737 enter a steep dive, begin to recover, and then dive again into the ground? I'm Richard Godfrey. Welcome to Independent Aircraft Investigations. On the 21st of March 2022, China Eastern Airlines flight MU5735 departed Kunming for Guangzhou. At 14:20:55, radar showed the aircraft leaving its cruising altitude of 29,100 feet. Air traffic control called the crew immediately, but received no reply. What followed was not a normal descent. Just 45 seconds later, the aircraft had descended to 11,000 feet at a ground speed of 545 knots. Then the radar signal disappeared. The aircraft crashed near Langnan Township in Guangxi, killing all 132 people on board. The impact site was a small, deep crater, consistent with a high-energy, steep descent. To understand what happened, we reconstructed the descent. The descent takes 120 seconds. We're showing this at 10 times speed. At around 7,000 feet, the aircraft begins to recover, but then it dives again. Compared to a normal descent on this route, the aircraft was descending about 15 times faster than expected, reaching a maximum descent rate of around 30 times faster than normal. Over those 2 minutes, the aircraft traveled 27 kilometers horizontally. The vertical distance was 9.3 kilometers, giving an average flight path angle of approximately 19 degrees. The weather in the area was fine at the time, 29 degrees Celsius, light winds, light rain. The top of descent occurred in the same area as previous flights on this route. This is the crash site. By comparison, here are images before and after the impact. Major pieces of the plane's wreckage, including the vertical stabilizer, left and right engines and wings, and the landing gear, have been recovered. The plane's 2 black boxes were severely damaged in the crash, and data retrieval and analysis was still underway a month after the crash, when the preliminary report was released. The report reveals that the flight's crew and maintenance personnel met the relevant standards, and the plane's airworthiness certificate was valid. There were no items on board that had been declared as dangerous goods, nor any forecasts of dangerous weather. Before the plane deviated from the cruising altitude, the radio communications between the crew and the air traffic control department did not show any abnormality. According to the preliminary report, the investigation team will continue with its work, which includes debris inspection and flight data analysis, to find out the cause of the accident in a scientific and meticulous manner. That was written now 4 years ago. The initial response from the CAAC was published on the 22nd of March, 2022. These are simply operational, political, and safety control communications, not investigation outputs. The crash was confirmed, the emergency activation, and leadership directives and safety messaging. The only information, the passenger count, 123 plus 9 crew. Confirmation of the crash, activation of emergency response, and instructions from leadership. 0 investigative data. Between the 30th of March and the 18th of April 2022, there was an industry-wide safety reaction, a sequence of system-wide safety inspections and oversight actions. Regional inspections, both remote and on-site. And the only information we were given, the audit structure, inspection of 6 aspects. The oversight activities were across airlines, ATC, and airports. Again, no aircraft-specific investigative findings. The preliminary report was issued on the 26th of April 2022 and is the only investigation-related document that has been released so far. It is a one-page summary and based on the ICAO Annex 13 requirement. Purely factual, no analysis, no cause. It includes a brief radar timeline, basic wreckage information, and crew and airworthiness compliance. What does not exist is a final report, any interim technical reports, any systems analysis, the CVR data, any wreckage reconstruction, or any progress report hosted by the CAAC. Later publications from the CAAC include an ICAO forum in 2024 and an IATA legal symposium in 2025. But these are purely diplomatic and industry events and completely unrelated to the MU5735 investigation outputs. So the current status, CAAC has only issued a one-page preliminary report officially. There's no final report, and the only other statements are announcing the crash, safety inspections, and ICAO IATA meetings. Compared to standard Annex 13 practice, typical authorities like the NTSB or BEA or the AAIB UK would have issued a preliminary report in full after 30 days, given factual updates, docket releases, interim findings, and a final report often within 1 to 3 years, which is missing in this case. So the flight MU5735 case is very unusual in 3 different ways. A single minimal public investigation output, one-page summary only, no progressive disclosure, and no technical updates whatsoever. They separate safety actions from cause investigation. They discuss extensive safety campaigns, but 0 causal transparency. The entire disclosure consists of emergency response notices, industry safety actions, 1 preliminary report, and no follow-up investigation. In May 2026, previously unreleased NTSB recorder recovery material associated with the investigation DCA 22 WA102 became publicly accessible through an FOIA disclosure. The release materials included flight data recorder parameter plots, cockpit voice recorder recovery documentation, recorder power loss analysis, and flight control and force traces during the initiating phase of the event. The release plots show that while cruising at approximately 29,000 feet, both engine fuel cutoff switches moved from run to cutoff. These switches are guarded controls designed to resist inadvertent movement. The switch transitions preceded the onset of the major descent sequence. Engine N2 speeds decreased afterward. Autopilot disconnect indications followed. Active flight control inputs continued during the initial descent sequence. The released FDR data records approximately 23 seconds after the fuel cutoff event, before recorder power loss following engine spool down and generator cutout. The NTSB documentation also states that the cockpit voice recorder recovery quality was excellent on all channels, and the CVR continued recording on battery backup power after aircraft generator loss. This information materially changes the publicly available evidentiary picture. However, the full synchronized FTR dataset has not been released publicly. No official CVR transcript has been published, and no official final accident report has been released by the CAAC. The released recorder plots alone cannot establish crew decision-making, cockpit interaction dynamics, or the identity of the individual who moved the switches. The disclosed data strongly supports the following high confidence conclusions. The primary flight control linkages remained mechanically intact. The airplane was under active manual control during the upset. Significant forward column force was applied. Elevator and aileron movement corresponded correctly to cockpit inputs. The upset was not solely an autopilot-driven event. The aircraft response was dynamically consistent with the commanded control inputs. We can also say with moderate confidence, one control station may have been exerting greater force than the other. There may have been partial opposing inputs or resistance. The forces appear more consistent with sustained human input than transient malfunction. What we cannot conclude definitively is which pilot made which input. We cannot determine intentionality or psychological state, and whether a control struggle definitively occurred, and whether the inputs represent deliberate dive command or to what extent failed recovery attempts. The MU5735 FTR data released by the NTSB is very difficult to reconcile with a purely passive aircraft upset or a simple mechanical failure scenario. The force-position-response relationship strongly indicates active human control inputs throughout the critical portions of the event. The disclosed FDR data, especially when combined with dual-engine fuel switch movement to cutoff and no apparent relight attempt, is strongly consistent with deliberate crew action and difficult to explain by ordinary mechanical failure, automation anomaly, or inadvertent upset alone. Only the release of the full FDR data and the CVR transcript will answer the open questions. The CAAC should release the complete synchronized recorder evidence in order to resolve the remaining causal and human factor questions with high confidence. The released FDR interval captures the initiating sequence, but not the full descent chronology through impact. So what information is being withheld? Based on Annex 13, the following almost certainly exists internally, even though CAAC has not released it publicly. They released the initial information package that there was an accident and a very brief summary, 1 page, but then the public trail stops. There should be a formal accident notification package, which they should have sent to the ICAO, China as State of Occurrence, Operator and Registry. They should also send it to the US, the State of Design and Manufacture of the Boeing 737-800, and plus to any involved technical advisors. Annex 13 sets out the notification, investigation participation, preliminary report, and final report processes. There would have been an ICAO formal preliminary report, but we have not seen that in the public domain. We've just seen a summary of the report. Annex 13, Chapter 7 requires an accident data report to ICAO as soon as practicable after the investigation. And this is for any aircraft accident for an aircraft over 2,250 kilos. If the investigation is still formally open, this may be incomplete or not yet finally transmitted, but the ADREP data file work product should exist. There will also be a draft final report, but no interim report followed. Annex 13 expects a final report to be made publicly available as soon as possible, preferably within 12 months. And if not, states are expected to release progress information on an annual basis. Since no final report has appeared publicly, it would be reasonable to expect an internal draft or working materials exist, even if there's not a complete and approved final report. The following records would normally be expected to exist in an Annex 13 investigation, but they have not been released publicly by the CAAC. Their contents, completeness, and conclusions cannot be verified from the public record. These are not necessarily Annex 13 public documents, but they are typical investigation work products. We do have now the FDR and the CVR handling records from the NTSB. The public preliminary briefing said both recorders were severely damaged and that data retrieval and analysis was underway. We now know from the NTSB the CVR data was fully recovered, and the FDR data was partially recovered. That implies an internal chain of custody records, recorder condition reports, readout attempts, data recovery logs, and analysis notes. Next, there will be radar and ATC evidence package. The CAAC preliminary page gives precise radar times, altitude, speed, and heading. That implies underlying radar plots, ATC recording, controller transcripts, communications logs, and surveillance data reconstruction. There will also be wreckage distribution and impact site documentation. The CAAC states the report covered wreckage distribution and identifies the main impact crater, recovered major wreckage, engines, wings, landing gear, and stabilizer. This implies site maps, wreckage tagging, recovery inventories, photo logs, component examination sheets, and probably a wreckage field database. CAAC publicly states the crew and maintenance personnel met relevant standards and the airworthiness certificate was valid. That conclusion requires internal records on licenses, training, medicals, duty and rest roster, maintenance history, MEL and CDL status, defects, and continuing airworthiness. The CAAC state no declared dangerous goods and no dangerous weather forecasts were present. That implies cargo and load documentation, dispatch release, meteorological package, SIGMET, TAF, METAR review, and possibly satellite and radar weather review. No systems analysis was released. The following documents are likely available, not necessarily publicly, but Boeing, NTSB, and FAA technical correspondence will exist because the aircraft was a Boeing 737-800, and the US was the state of design and manufacture. Given the accident profile and high energy impact, internal group work almost certainly examined flight controls, autopilot, stabilizer, elevator, engines, structural breakup, avionics, and human factors. But without the unreleased report, we cannot say what each group concluded. Publicly, CAAC has released only the one-page preliminary briefing. Internally, Annex 13 and the CAAC page itself imply a much larger unreleased record, with the formal ICAO submissions, ADREP materials, recorder work, ATC radar files, wreckage mapping, crew maintenance airworthiness files, weather dangerous goods screening, and a draft final report. No CVR transcript appeared. Investigators would want to know who verbalized the fuel cutoff, whether there was surprise, whether challenge response occurred, whether either pilot questioned the action, whether there were sounds of physical interference, whether engine restart was discussed, whether checklist callouts occurred, and whether there was silence during key periods. That is why major accident investigations normally rely on the integrated reconstruction of the raw FDR, the full CVR, aircraft systems analysis, human factors, medical and toxicology, operational history, maintenance history, the ATC timeline, and wreckage examination. Flight Radar 24 provides what we call Tier 2 data. Tier 1 is the official reports, but Flight Radar 24 ADS-B data constitutes independently collected, non-official surveillance data derived from aircraft transmissions. While not part of the official investigation record, it is generally considered technically reliable for reconstructing the aircraft's trajectory, subject to the normal ADS-B limitations. Flight Radar 24 wrote an article on the crash and included the ADS-B-based trajectory reconstruction and high-frequency granular data at 2 Hz sampling. Aircraft reported parameters such as altitude, vertical rate, and position. And the key factual points they state: the cruise was at 29,100 feet pressure altitude, a rapid descent beginning at 0620 UTC, a brief recovery to 8,600 feet, and then a second rapid descent. Their last data point was at 3,225 feet. They also explicitly clarified the vertical rate comes directly from the aircraft computers. ADS-B has its limitations, and it is not safety certified data, susceptible to reception gaps and latency and decoding artifacts. But the vertical rate was derived from onboard sensors. However, ADS-B is not equivalent to the flight data recorder data. Independent Aircraft Investigations has conducted an analysis of the horizontal and vertical trajectory based on the publicly available ADS-B data and derived from the Tier 2 surveillance data, and is not part of the official investigation record. In total, there were 17 ADS-B data points over the last 2 minutes of flight. The track over the ground is shown, but it's not necessarily the aircraft heading, because it depends on the wind strength and direction. The steepest sustained descent phase observed in the ADS-B data is the first main rapid descent, averaging about 25,000 feet per minute over 46 seconds. The final observed descent also becomes very steep, averaging about 21,000 feet per minute over the last 14 seconds. These are ADS-B-derived average rates between received data points and not FDR-validated vertical rates. The peak instantaneous vertical rate may be higher than these averages, but cannot be reliably determined from ADS-B sampling resolution. The maximum recorded vertical speed was 30,976 feet per minute, and this speed was reached 3 times, twice during the initial descent and again just before the crash. We also use the ADS-B data to derive the flight path angle. We took the ground speed and average vertical rate data, and the main descent phase imply flight path angles of approximately 20 degrees to 27 degrees. The recovery phase implies a brief positive flight path angle of about +8 degrees. The associated vertical acceleration changes suggest a kinematic transition consistent with low G and unloaded flight, followed by a possible pull-up in the order of 2G in a simplified vertical plane model. These are not FDR-derived load factors and should be treated only as kinematic implications from ADS-B data. Vertical accelerations are estimated from changes in vertical rate over time and do not represent direct load factor measurements. A peer-reviewed study published in the Seismological Research Letters analyzed the crash using seismic waveform data recorded at a station approximately 21 kilometers from the impact site. This analysis uses independent ground motion measurements, applies waveform inversion techniques, and is also not part of the official investigation record. The key findings from that research: an estimated impact dive angle of 38 degrees, an estimated impact speed of 200 to 264 meters per second. That's 390 to 513 knots. An estimated peak impact force of 8.8 times 10 to the 7 newtons. An estimated impact time of 14:22:38 local time. And the study finds that the impact was not vertical. The descent angle is consistent with the radar-derived estimates. The limitations of the study are also mentioned. It's only based on a single seismic station, and its study was dependent on several model assumptions and requires validation against the flight recorder data. However, the study on the seismology aligns almost precisely with the kinematic study from the Flight Radar 24 data. The Boeing 737-800 aircraft's descent was already very steep during the main ADS-B descent phase at around 27 degrees, and then is consistent with further steepening towards impact, reaching approximately 38 to 39 degrees. The 39-degree value based on kinematic estimate is very close to the 38-degree value based on the seismic data. So what is our conclusion? The publicly released NTSB recorder data materially changes the evidentiary picture surrounding flight MU5735. The release flight data recorder plots indicate that while cruising at approximately 29,000 feet, both engine fuel cutoff switches transition from run to cutoff prior to the development of the steep descent sequence. The recorder data further shows engine spool-down followed the switch movement, autopilot disconnect indications occurred afterward, active flight control inputs and left and right and local and foreign control force activity continued during the initial descent phase. This is consistent with an aerodynamically controllable aircraft during at least part of the event. The release data also shows that the initiating event preceded the major upset dynamics observed in the ADS-B and seismic reconstruction. The flight data recorder ceased approximately 23 seconds after the fuel cutoff sequence began. due to loss of aircraft electrical generation. However, the NTSB documentation states that the cockpit voice recorder continued operating on battery backup power and that recovery quality was excellent on all channels. This means investigators possess cockpit audio covering substantially more of the event than is publicly available. Unlike the FTR, the CVR continued operating on independent battery power after generator loss and likely recorded much of the remaining descent sequence. The released recorder plots materially constrain scenarios in which the steep descent originated solely from weather, structural breakup, or unexplained automated flight behavior. However, the currently public evidence still does not conclusively establish the crew coordination dynamics, pilot incapacitation, which individual initiated the fuel switch movement, and the full sequence of crew actions during the descent. The unreleased synchronized CVR evidence remains the single most important unresolved source for determining the cockpit sequence and probable cause of the accident. Many thanks for watching. And if you like this investigation, please subscribe to ensure future independent aircraft investigations.